welcome to my channel Tech with Says. Today we will discuss about content security policy, and this policy is very important in terms of UI security. Like when we develop any UI application, we must secure it, right? We do it every time. But this policy gives an extra layer of security to our application. So we will see like what are the various aspects of this policy and how can we implement it. But before we go into that policy level, why we need a policy at first place? Because thing is that whenever we have any application like a UI application up and running in the internet, basically then anybody like any hacker or attacker uh, may identify some vulnerabilities into our application, and then they can inject their malicious script into our application, because like whatever UI applications we render on the UI, right? They will be having a lot of JavaScript, style sheets and images. So it will coming from various origins. So if there is some vulnerabilities in our application, then attacker might exploit them and inject their malicious script. So what happens when they inject their script? They can steal the information of the application. Maybe they can steal the session keys or session tokens, or maybe even if they can get the session information, they can log in as a user and they can do whatever a user can do. So it's uh, what we can say that the, this cross-site scripting attacks are when happens whenever a attacker can identify any vulnerability into our application, and at the browser side or you can say client side, they can inject their malicious script and execute it, and they can get the information, any sensitive information from our application, and they can basically utilize that for their benefit. Or maybe sometime they can basically deface your website. Maybe they can put some images which are objectionable, or some styles they can change. So this is like a attack which can happen into our websites or any UI screen. So yeah, so let's see how it works. So like whenever we have any application running up and running, and user want to basically access it, right? So user will simply connect to that application, then the application basically will get information from the backend web server, and it serves those information back to the user. So it's a happy path. There is no issue in that. But suppose our website or UI screens are not that secured, then what happens? Then any hacker come into the picture. They can inject their malicious script and get the information from, or basically they can hack our application. So basically, this XSS attacks or like uh, cross-site scripting attacks can happen whenever there's vulnerability into application. So that is the main problem any website faces, or maybe we need to remediate it before it's too late, right? So yeah, so let's also see like what are various types of the this kind of attacks. Like what are the various type of the CSS attack? Maybe like first is the reflected cross-site scripting. In this, what happens that whatever the attacks the attacker do, they do at the client side. So whatever script they want to execute it for their benefit, they will execute it at the client side, and so that the web server will not be aware about it, because they will not save that script into the database or in the web server side. So this type of attack basically a non-persistent attack. Second type of attacks which can happen to our website, that is the stored attack, like stored cross-site scripting. In this, what happens that attacker is able to save their malicious script into the backend database or maybe in backend web server. So every time whenever a new user try to load that page or visit the website, it will again and again execute that malicious script. So, for example, like in our YouTube world, right? So, for every in every video, below people put their comment like they ask questions or they basically reply to those question answers. So, but what happens maybe if somebody want to hack it, they can put some script over there. So because all the comments will be going back into the database in the backend to save it. Then that malicious script also will be saved in the database. So that is the problem because uh, that comment will be coming up for every loading of that particular video. So this is basically called as a stored attack or stored sorry, scripting, we call it. Then the third one is the DOM based attack. Basically, the every HTML page is basically made up of the DOM model, like DOM document object model. So what happens that attacker basically modifies the DOM in such a manner that whatever the script, which is legit script, I mean the script coming from the our application, that will be running fine. After that, whatever the modifications they have done, like whatever the malicious script they have inserted, that will also run. So that's how they will be able to steal the information. But we will not know as a app developer or app owner will not know because there will be no logs coming into the web server side. And that's why it is very difficult to catch this type of issues into the applications if they have like anything like this attack. Last one basically is the self-access. Basically, in this, what happens that users are lured by the hackers to click on some link. So maybe they can be asked to put some code on the developer console, like when you press F12, that console, and then this script can be executed. So yeah, so these are the various type of the cross-site scripting attacks which can happen to our websites, and that is and then it might be a problem for security of our application. So yeah, so how do we stop it? Like, okay, these are attacks we understand, but how do we stop it as a UI developer or as a app owner? So there are various ways to basically prevent or secure application. Like first is the we can escape the inputs, right? Whatever the input we are getting it, we can escape them, right? For example, for any control characters, suppose somebody has put any any symbols like there's an equal to symbols, those we can treat as it string only. So that it won't be basically being thought by application that okay, some control character, maybe some script character. So that's how we have to treat every input coming from the application as a string and convert to a string before going ahead in the application. Then whatever input we are getting from the application, maybe like a form or maybe some text box, those we have to validate it based on the business logic. And also, we have to sanitize data. Whatever data we are getting, we should have to validate it before moving ahead in the application. Then, whatever output we want to render onto the UI, we should always encode it so that basically it's difficult to modify by any hacker or attacker. Then I mean we can use the right response headers so that the browser will understand okay what kind of output they are rendering into the applications on the UI so that the hacker or attacker is unable to inject the malicious scripts. Okay, so these are the existing ways by which we can secure our applications. But in this video, we are talking about basically the security policy, like how can we secure our content by this CSP. So let's go through that policy thing. So yeah, so as I explained initially in this video that the security policy for content is basically an extra layer of security. Is not that it is only way to make our app secure, but it is an extra layer of security. It's basically an HTTP response header. So whatever the response you are adding to your response back to the browser, so it's part of that. And then basically what happens, the major role of this policy comes where we can basically whitelist our resources, right? For example, for any UI application, UI rendering, right? Any so we need the JavaScript to execute. We need the images. We need the styles. So those to be controlled by ourselves because if somebody else is able to modify at runtime, then it's a problem. So this policy help us to make sure that the content is rendered from our resources. Maybe the resources can be self. When I say self means that the resources coming from the application itself, like the app directories. Then they can be from any URL, which we test so that any third party URL, any third party content will not be rendered and it will be stored by this CSP policy. So, okay, so what are various resources we can protect by the this CSP? So we can protect the our script. Script are the major portion where uh, mostly attack happens, like script styles, images. So we'll look into all these things one by one. And the major focus I'll be doing on the script because normally hackers are able, when they are able to inject their script, they are able to execute their particular code. So that is a bigger threat, right, than any other thing. So, and also if you want to like, because there are so many directives defined by the security policy. I'll be just going through few of them. But if you are interested, you can go through those other as well in this link. It is given here. So yeah, so suppose you have an application like UI application, and you want to secure your application by the security policy. So what you can do, you can add this header over there, and then basically, I mean, all these are called directives like script source, style. So these are all directives, and we will see one by one. So, but this basically depicts an sample code, like what we have to add into our applications to make them use this security policy. So, for example, suppose you want to secure your JavaScript. So, to secure your JavaScript, what you can do in the meta header, you can add like this: a script source, then self, and whatever URL you trust. So what it means? It means that whatever the content we want to render on the UI, that will be served either from self, means the content which is coming as a part of our application directories, or from this URL which we test. That's why if you see here, right, this one, whenever we have a JavaScript running from the app directory, it is going to be allowed. Same thing, whenever we have JavaScript being rendered from this particular URL, which is part of this policy, this allowed. But if some hacker want to execute their own malicious script, like from some other URL, they won't be able to do it because security policy will stop it. Because this security policy knows, okay, these are the tested places, origins from where I have to load the script from any other source. If somebody is trying to load it, I have to stop it. So you will see the error coming in the developer console or maybe in the logs if it's configured properly. Then like, okay, so like one issue we always face that in in legacy applications or maybe applications which have been built earlier, we have a lot of inline script, right? So like this, we have our script between the script tags, and in between we have some code running like a JavaScript code running in between that, and also like some event like button on click or maybe like that event handlers like on click, on load, on mouse hover, all those event handlers are there. They are basically like a inline script. So all the inline script are blocked by CSP by default. So as soon as you enable the kernel security policy into your application, it is going to block all the inline script. So sometime when we want to remediate or utilize this policy, it becomes bottleneck because suppose you have a tons of JavaScript running into your big application and you enable CSP in your application, then it's not going to work. The UI will not be loading and you will see bunch of errors coming into the logs or console. So basically, yeah, so by default, inline scripts are blocked. But suppose you want to utilize the security policy, but you also have the inline script. So there are various ways by which we can do I mean, basically the ways we can turn around this thing. So like we can use unsafe inline. So what happens that if you have used the unsafe inline in the policy script source directive, then it will allow that inline script. Okay, but it is not a good way. It's not a recommended way. Even if you see the directive name, right, it says unsafe. So unsafe, I mean, this is like itself it's saying, okay, I am unsafe. Don't use me, please. But for time being, suppose you don't have time, you have release coming nearby, then and you have a lot of JavaScript, you cannot refactor those. Then for time being, you can use like unsafe inline, but long-term objectives would be to move away from the unsafe inline. So this will basically enable us to basically enable CSP with inline script. Otherwise, inline scripts are not allowed in the CSP policy. Okay, so suppose, okay, so you want to secure the application, right? And then what are the ways by which we can be sure that, okay, whatever JavaScript I am loading, that should be rendered, not any other JavaScript. So there are like couple of ways, like one is the hash-based security policy. In this, what we do, we basically generate the hash of this function, whatever the function name you have you can basically generate by SHA-256 algorithm. And then once we get this hash number, we put this hash number in the security policy. And then in our application, wherever you have that JavaScript, right, you attach it, this number, okay, like in the side by side that after one white space, you can put it. So what happens that in your application, you generate hash, you have put it that hash in the policy, then also in the script which you want to run. But suppose now hacker want to run their script, they cannot do because this hash number is known to you only. The hacker has no way to know this hash number. So even if they are able to maybe get some vulnerabilities explored into our application and able to inject some malicious script, it won't load because their script will not be having that particular hash number. Okay, so that's how we can secure our application. But there is one issue with this approach that whatever the function, right, you have to get that hash of that string. So in case you are changing your function name, maybe in future, or maybe some other developer is doing some refactoring, or maybe by accidentally he or she has added one byte space, then this hash become invalid. So in that case, you have to again generate the hash number and put that hash number into all those JavaScript. So it become a very cumbersome, sometimes basically a lengthy process to maybe you have fixed everything, went to the UAT or production, and by mistake one white scripts were added. So yeah, so in that case, UI will not work. So this should be kept in mind. So what is the next option we have? We have one more option, like we can have the nonce-based like cryptographic number. That number is a random number. So randomly you can generate a number that you can put in the security policy. Also, you can put that nonce number into each script, right? So so what happened that same thing like whenever a hacker want to hack your application, they will be trying to inject their script, but they cannot because the nonce, right, that number is only known to you or maybe unique to your application. At that time, they're strictly blocked by our security policy because that number is unique to our application. And also, one more thing that this number is like not linked with any code, like not with functions. So it's not like that somebody is adding any white spaces or changing functions. So you have to again generate it. So basically, with this random number, you can secure your JavaScript and secure your application. And one more thing I have seen that some people use the static nonce. So that basically, suppose they have uh, like just fixed nonce number, maybe some long string. Not good, because maybe if somehow your nonce number get leaked, then still hacker can again hack your application and they can do whatever they want to do. So the recommended approach is to use a dynamic nonce for every request. Generate a new nonce. So basically, for suppose you have one request coming from user, okay, generate a new nonce, attach it to the scripts. Same thing you can do for all requests, so that every time you have a new nonce and nobody can guess it, and that's the way we can secure our application in a better manner. So yeah, so sometimes people ask that, okay, which one to use? So hash versus nonce. So whenever like we have like single page applications, so single page applications are like we don't refresh each part of it every time. So it's better to have hash based, because for nonce based applications like which we are rendering from the server side, so we have an opportunity to get a new nonce number every time. So whenever a request is served by web server, it can generate a new nonce number, a random number, and attached to the script. So I think the applications which have the single page applications that are good for the hash-based approach, and applications which are like rendered from the server side, it's good to use nonce. But like yeah, so again I will repeat that whenever you are trying to use nonce, try to generate dynamically. Don't use static number, okay, because that is going to defeat all the effort which you are putting into your application. Okay. Yeah. So till now we have focused on the scripts, right? Because scripts are the most vulnerable things, and but apart from script, also like images and images and styles also important to secure them. So same way, like we have done for script, same thing you can do for images also. You can define the origin site, which origin you want. You test it, like you test yourself, or you test also the some URL. So only those images will be allowed to render on the UI. Apart from those images, nothing will be rendered and they'll be stopped. So that's a way you can secure your images. Then, yeah, suppose you have some object, right? Same thing you can do like any applets or any object which are embedded, you can define from where you want to render them. You want what is the origin you don't trust any other origin. So those things you can define like in object source policy, and we can secure our objects as well in the UI applications. So moving ahead, yeah, same thing for styles also. So styles whatever style you want to prefer into your application, colors and design. So they also are important things to secure. So same way you can define like from which place you want to serve the style thing. So maybe some directory or URL. So you can basically define as per your requirement. Even the nonce and the hash also work for styling images. So the idea is that for any application, generate nonce for the script, images, styles, and use it. Okay, so that attacker or threat actor cannot inject their basically scripts or their images into our application. So sometimes what happens that yeah, so once we are developing the applications, right, so it's not possible to uh, basically because whenever we rent, I mean we develop something right, we have to verify that the policy which we are putting into the application is fine or not. So for that, maybe if we change something, it might break the application. So before making it live, right, whatever code changes we have done for this security policy, what we can do, we can define the policy as a report only policy. So what happens if any violations are happening on the website while running the application? That is going to be reported into this URI link. Okay, one URL you can define. So here, what all those JSON resources or payload will come, and those you can check. Okay, this is the error coming from my application, and then you can fine tune the application, and then you can again make it change and fix it. So okay, so this feature is very important, like for existing applications. Those are already live and you are trying to implement the security policy, but you want to make sure that it's not breaking the policy, making the application at all. So at that time, you can use this type of report only policy, and basically you can test application. Same thing also like in production, what any if any error comes, right? So you don't know like from for which user it came. So what you can do, you, you can go to this URI link and uh, ch- uh, you can basically see the JSON loads and verify the data. Okay, so let's see like whenever you are implementing the security policy into your UI application, what are the best practices we can follow? First thing is that there should be a way to disable the CSP in production. Suppose you have put in this security policy into your application, but there's some issue coming, right? So you don't want to go down for hours. So maybe you can disable the security policy and then you can debug and fix and come back and enable it later. So this is very important from the prod point of view. Then, whenever you are implementing this policy and you are not sure, then you can switch back to that report only policy. At that time, any error comes, any violations comes, you can basically get the JSON payload in that URL and you can analyze it, fix the code, fine tune it, and then you can again change whatever is required. Then whenever we are defining in nonce, right? Suppose you are going with nonce, then we should always define nonce for like each request. Sometimes people define the nonce like statically, so it's not good because a static nonce can be easily be detected by the attacker or hacker. So it's better to define dynamic nonce. And maybe for each resource, like suppose you have JavaScript and you have images, you have styles and few other resources. For those, you can generate different nonces. Okay, for every request. It's a good practice. Then suppose you have multiple policies, right? Suppose you have multiple policies. So, I mean, you can define them, but issue is there that whenever you have one policy saying one thing, other policy saying other thing. So, if all policies like are congruent, right? If they agree with each other, then only the resource will be loading. So if suppose there is some policy says don't load this from this origin, some says load from this origin, so it won't work unless until all the policies agree on particular thing. Until that point, the rendering will not happen for the resource. Then it's a good practice to remove all the inline scripts and inline event handlers. So for this, what we can do, suppose you have mm, many lectures of JavaScript, inline JavaScript and other sources. So what you can do, you can basically refactor application and move all JavaScript to separate files or maybe one file. Similarly, for styles, you can also move it to a separate style sheet. Then, whenever any event, suppose on click button, on mouse hover, whatever event, right? For that event, you can invoke it. And apart from this, also use the hash or nonce to be like more secure application to basically to make it more secure. Yeah. So. That's it for this presentation or video. So if any questions you have, you can put in the comment below, and I will try to answer them. And please, if you like the video, please subscribe, comment, like, and yeah, ask questions. I will try to answer them. And thank you for watching the video. Thanks a lot.